Alright class, here's number 45. So this is the setup here. We have a vector going from the origin to A, from the origin to B, from the origin to C, and they're holding up this 300-pound weight. So the first thing you need to do is make vectors. Since they're all starting at the origin, the vectors are actually really easy. OA is going to be 0, OA is going to be 0, 10, 10. OB is 4, 6, negative 4, negative 6, 10. And then you have OC, 4, negative 6, 10. Alright, so video cut out, but we'll try to pick it up where we left off here. So we have, so what we're going to try to do is add up all the forces in the x direction, and they should equal 0. So that's what I've started to do here. You've got to add up the forces and divide that by their magnitudes. So 0 up here divided by the square root of 200 times vector A, and I'll just call it A, B, and C from now on. Then we have negative 4 divided by the square root of 152 times vector B, the magnitude of vector B. And then lastly it's 4 divided by the square root of 152 times vector C. In the J direction, we're going to have 0 force, so it's going to be 10. Again, divided by the square root of 200 times A, minus 6 divided by the square root of 152 times B, minus 6. C divided by the square root of 152. And lastly, and that's great. Lastly, but I'm just going to have to put it up here. Put it right up here and I'll write smaller. Last equation is going to be 10, 10, and 10. So 10 over the square root of 200 times A plus 10 over the square root of 152 times B plus 10 over the square root of 152 times C. And now this one equals 300. So you have 3 equations. All you have to do now is put them into your RREF and get the answer to solve for A, B, and C. When you do that, you should get an A magnitude of 159.1, and since our weight is in pounds, this will be pounds. B is 115.6, that's also pounds. And C is the same, 115.6 pounds. Alright, hope this helps.